Hello guys, in this video, I will be showing you guys how to read a forecast weather balloon sounding by weather models. Let's get started. Weather balloons give a variety amount of detailed data for meteorologists to look at on severe weather days. Weather balloons give us a picture of the entire atmosphere. We can see if the atmosphere is rotating, see how much moisture is in the atmosphere, wind shear and tornado energy. Today we will look at what a sounding looks like and how to read it. Let's start with the Skewt chart. The Skewt chart has the two lines with the green and red lines going up with the dotted line off to the side. At the bottom here, this shows the temperature and dew point temperature at the surface. Just above the temperature values, the green and red lines are very close to each other. When you see this, it means there is plenty of moisture in the atmosphere. Since we all know that storms need moisture, we make sure these lines are touching or almost touching to ensure there is enough moisture in the picture. You can see the higher we get up into the atmosphere, the more the dew point line, the green line, gets away from the red line, the temperature line. This means there is lots of dry air in the atmosphere. However, since we don't really pay attention to the upper levels, since all the weather is happening at the surface, we don't pay attention this high up. If you look off to the side, you can see which part of the atmosphere you're analyzing. Right now with my example, we're looking at somewhere near 600 millibars in the atmosphere, which is pretty high up. On the far right side of the Skewt, you can see these symbols going up. These are called wind barbs and they indicate how fast the wind speeds are and what direction they are coming from. In this example, winds are blowing from the southwest. If you look closer, you can see spikes on the barbs. These spikes indicate how fast the winds are. If you look off to the top right, next to the Skewt chart, there is another line that is curving. This is called a hodograph. A hodograph measures what the balloon looked like when traveling up. In this example, you can see the hodograph is curved. This is called a streamwise hodograph, and it indicates that the atmosphere is rotating. If you look closer, you can see numbers. These numbers indicate the wind speed in knots. Right now the hodograph is showing 50 knot flow in the atmosphere, which is pretty good for tornadoes. If you look just below the hodograph, you can something called the critical angle. The critical angle shows how sharp the hodograph is. Right now, it says critical angle 69, which is good for a tornadic environment. Now let's look toward the bottom of the Skewt chart. There is a list of items: CAPE, SIN, LCL, LI and LFC. CAPE is short for convective available potential energy, and it shows how unstable the atmosphere is. In this example, it shows 882 CAPE, which is not a lot but it's decent. Next is SIN. SIN is short for convective inhibition, and it measures if there is what's called a cap present. If this shows anything about 30-50, it means the cap could be strong enough for storms to die quickly. Next is LCL. This shows how high the clouds are and it's measured in meters. In this example, it shows clouds will be around 225 meters above ground. We look at this because if cloud bases are low, tornadoes will have a short ride down to the ground, so tornadoes will be a threat. Next is lapse rates. These measure how fast the air temperature drops with height. In this example, the lapse rates are around -5 at the surface, which is good instability. Finally is LFC. LFC stands for layer of free convection, and it shows how high up storms will form. Anyways, that's all for this very shitty video. Thanks for watching, and I'll make a part 2 later. Goodbye.